Hey Alihupa, and this was an attempt to say hello everybody in Swedish. I'm sorry, and welcome to my channel, Utsuki. So I haven't posted anything for a while because of some things. First of them was the attribute system. So I am working on another version of this, of my health and attribute system, but this one I want make a video about it because of some reasons. Like, for example, the first one, I don't want to spam the channel with the same content over and over. Second of all, the changes were mainly quality of life changes. Remember that I said that you could add methods to add the attributes and make your life easier. So for example, instead of creating the attribute ATP in every single entity you want to have it, for example, you just add to the either health system or attribute manager and add health, for example, and with a simple method called, you are able to have it, for example, in the walls, plants, entities like the player, enemies, and so on. And lastly, it's just because I want to have something particular, but actually the changes were so minimum that it is almost 100% recognizable. So don't worry, it's not something like I'm betraying you. So, and second reason, it's because I was making this scripts I will use in this tutorial. So now let me create a better introduction than this one, a bit more focused in this today content. Okay, so I've showed you how can you make a state machine, and also we used this state machine in order to make a turn system, right? And this and state machines actually once you start using it, actually is mind-blowing and very, very efficient and helpful in order to make universal codes. Let me put it this way. If you have something, for example, to walk towards something and so on, just create states that can be used throughout the whole game, okay? But I think this is not enough. Like back in 2017, when I used to use Unity 3D to make my games, I already heard something about behavior tree that time. And nowadays it's not that different. But to be honest, I don't like behavior trees. I am not sure it's because that how visually, let me put it this way, it looks like, but to be honest, it's not something that I like. And since most part of the examples out there, it's mainly like plugins that not worthy, obviously, to create one by yourself. To make more complex entities, I need to have something that resembles these behavior trees, because these behavior trees are basically that what we used to call, and we are still calling, AI, artificial intelligence, but not obviously the generative AI. Is the AI that works like a brain for a character that would decide what will be the next state for them. And the behavior tree use the tree nodes of the entities, such as in Godot here, and the node tree, in order to decide and organize as well what can be the next state. But I don't like it, so I tried to make something by myself. So let me just example some possible usages so you can get a little bit more grounded what I mean. So Imagine, for example, you are making a management game, like a tycoon game. And imagine you have an employee. This employee, for example, handle the documents. And this employee must, for example, get some document and either deliver some of them, shred some of them, store like digitally some of them, and basically work in this way. Okay, so this is a whole behavior. This is not a single state, and we could think of how we could implement using that idea of turn system, but it would only work once, right? Unless we refill the state queue. But let me go to the very, not that much extreme, but an upside direction. So imagine you are making a boss fight, and there is tons different of ways how to handle and create boss fight. But imagine you have a boss with the very first state machine. You could have, for example, this boss hitting just in front of it, for example. With the turn system, for example, you could the boss hit in front and wait for the player, then open the player finish its turn, so it's the boss turn again that will hit in front of it, and so on, okay? But we need a bit more, how can I say this, conditions to decide which state we want to have it. And since it's the next step of the idea of a state machine, and not in complexity, because in my opinion, making an inventory where you are able to have different designs and holes, for example, inside of an item, and you are able to rotate, for example, inside of a fixed inventory, and the other items auto sort in order to try to fit with this different item is way more complex to make this. I think the level and this stream of state machines, this is basically our next step of complexity. Okay, so basically every single tutorial I made here so far, I do not consume any type of tutorial or material in order to make mine, except that audio system that I used part of the recording part from the documentation of Godot. But this is 100% original. And what I mean by this is not a flex. This is once again a reminder that you are able to make this system even better. And not only this, I am exhorting support. I totally support that you modify this in order to fulfill your needs. Okay, remember, this is a system that you can change whatever you want in order to make it useful for you. Okay, so let me explain this script. It will be in the same format of, in quotes, boring tutorials, because I want to explain the logic behind this. Okay, so I create a script called state. Here I have a variable called behavior of type behavior equals to null. This is basically the state machine, okay, but I called now behavior. And it is on top because it's very important for the whole thing to work. I have my signals on start and on stop, and now we have on precondition, on condition, and on past condition. This is just a different ways that you are able to link more things to happen while this state is working without necessarily put everything inside of the process function as callables, for example. Okay, And also another signal on running out. I think I have a lot of examples how can you use this, but basically I also have here, for example, the remaining time and duration timer and time limits. So upon these things being setting up, okay, the remaining and the duration time limit, upon the timer reaches 0 or the remaining that is different for -1, so it is set, reaches 0, so this runout will be called. Okay, so I have this precondition, condition, and postcondition. So I have both. I have the signal and the callable. The callable will be the one that will be used to evaluate the condition, and the signals will be actually the one where the action must come from. Okay, so I have the name of the state, the timer, time limit. If it is set, it will be used by the state. I have the condition timer and condition time limit. So this precondition I will show you, but this precondition will be used in the start function, the post condition in the stop function, and the condition in the process function. But if you try to call it every single time, your game might actually have some performance issues. So this is where we have the condition timer and time limit. So basically we have the timer that upon reaches 0, the condition will be called and reset to this time limit. And in this case, I set 1 divided by 30. And since this is inside of the process function that is called in a fixed call of 30 FPS, basically this is being called by default every single frame. But by setting this, for example, 50. Now this will be called every 2 frames, just as an example, okay? So I already explained the duration timer, and duration time limits. So basically, if this is the states that must have that have a limit of usage, and upon this usage being set with the remaining timer of call or the duration time, it must actually not be called anymore. I have this weight that is also used in the spawn system, okay, but this will be used to the proportion, chances of this being called. I will explain when we enter in the behavior part, okay. The next state, that is an array of strings, but since Godot have some typed array as primitive types, let me put it this way, like native types of the system. So I am using it, but you could set array and between square brackets string, okay? And the weight is for this next state. This next state will hold the name of this state. So it is very, very important to set this correctly, okay? And not only this, the behavior as well will use the name of it. The iterator, the callable, I will explain soon, but this is the important part. The switching type and the type that it will hold the value of this. These variables together will be very used for a specific thing. So I want to explain exactly because I have more essential parts first. Where we have iteration, random weighted, and callable that will use this callable in order to decide which next state must be called. But this is a bit more advanced than the basic usage. So in the ready function, I set the name of the node equals to the name of the state. And don't worry if you have more than one state, because Godot actually adds the number after the name if there is node with the same name automatically. Okay, I set the process and physical process by default equals to false. This is very default path for the states. And here on the start function, I check if the behavior, that is the state machine, has escape precondition equals to true. If it is, I set to false. But If it is not, to skip, I check if there is a precondition, and if this returns true. If this returns true, I emit the signal on precondition and I return. So the start function actually won't be called. I check if the remaining is set, so it's different from -1, and if the remaining is lesser or equals to 0, so run out of times, I return. Else I decrement the remaining by 1. This is the timer and timer limit. So if the timer limit is set, so it's different from -1, the timer have this timer limit. So I print a starting state and the name of the state, set process equals to true, both process type equals to true. I emit the signal on the start, and I check if the duration time limit is different from -1. If it is, I set the duration timer equals to this timer limit. So, in the process function, I check if the time limit is different from -1, so it's set. The timer will be decremented by delta, and upon the timer is lesser or equals to 0, I call stop. The same idea of the duration and duration timer. If it is greater than, if the timer limit is set, the duration timer is greater than 0, I decrement by delta, else I reset duration timer and I emit on running out signal. And the condition timer is set, and the condition timer is set and greater than 0, I decrement by delta. Else, I reset the condition timer to the time limit, and I check if the condition, skipped condition is false, if the current state is processing, if the condition is set and returns true. So if it is, I emit the unconditioned signal. And here on the stop, so I print a stop state and the name of the state, set both process to false. If the remaining is lesser than is set and lesser than equals to 0, I emit the runout signal. I reset the skip condition because different from the precondition I set in the start, I don't set here in the process, okay? Because actually this condition would be only skipped once, so not while the state is processing. I check if the pass condition, skip pass condition is true, so I just set to false. Else, if the pass condition callable is set and returns true, I emit the onPass condition signal, and I emit the onStop signal as well. And I have this method getNextState. So I met the type. If it is the iteration type, I increment by 1. If the next iteration is lesser than the next state, because remember, I always say this, it's boring, I know, but I have to say array indexing start in 0 and goes to the size of the array less 1. So if I have an array of 3 positions, it actually goes from 0 to 2. So the iterator must be always lesser than the size of the array. If you try in the array of 3 position access the index 3, you will throw an exception. That's why it must be lesser than array size. Else, I decrement by the array size less 1. So actually, this increment by 1 will become decrement by the array size, or basically this set to 0. And I return the next state based in the iterator. If it is random, I use the RNG inside of the state machine to randomize between 0 and the next state dot size lesser 1. If it is random widget, I instead use rand widget passing the array of wages, that is a packed float 32 array. And if it is callable and callable is set, I basically return what the callable say. Okay, and like this is not necessary, but since I did not set a default path such as this, So I must return an empty string just to not throw an exception. Okay, so this is the state base script, and I created some states for you. So I have this behavior system because since I want to use this in different projects, I create a folder only for the things that might be very useful. So I am able to copy this folder to whatever I want. Okay, I don't need to actually reuse the project entirely, only this folder. So in the state folder, as you can see, I have the hug state. So I have the entity that is the like the player one, let me put it this way, the target that will be hugged, the speed, I will move toward the target to hug it, how long the hug must last, and the time limit for it. So in the init function, I set the name equals to hug. I check if the entity or the target is not set, so I am not able to neither move the player, neither like localize the target. So I just call stop and return. Set the hug timer equal to the hug time limit, and I start like set the process, check the precondition and so on. Okay, so in the physics processing, I check if target is set. So basically it must like be set, but just for the sake of everything work, I check here again. So I check if the player distance to the target is lesser than 4. So if it is, I set the velocity equals to 0, and I start counting the hug timer. Okay, so the hug timer, like if I must hug someone, in this case, for like at least 1 second. So this is the time how long I must hug. And upon this hug timer reaches 0, I stop. Also, so if I'm further than 4 units, I set the velocity equals to the target position less the player position dot normalized times speed. This is a very useful script if you want to move something toward another something without using the path finding. Okay, and the stop basically reset the target to null. Okay, so I don't always have to hug the same person if needed. Okay, the move to that actually use a very similar structure. So I have the target position that could be a vector 2, but since I don't want to like move set a default value, and the default value is basically vector 2.0, I set it to variant. Okay, so I set the is not set. In the physics processing, I set I check again just for the sake of everything, set the body velocity equals to the target position lesser body position that normalized times the speed, and I call move and slide this processing, and the distance is lesser or equals to 3, so in this case I used 3. Now the refill state, so I have the target position, the body, the speed, the name is refill. I basically move towards the refill, as you can see, and the difference, like before I stop, I set the documents inside of the orange that inside of the state machine, I will explain soon. I set the documents to a number between 0 and 9. Okay, just as an example, but I don't need this. But I wouldn't need this if I set actually another that I will show you soon. Okay, but this is the refill state. Now the shred state, because like for this refill and this shred is the office example, but I want to explain anyway. So I have the target position, body, speed, the number of files I want to shred, how long it takes to shred, and the time limit to it. But in my example, I didn't use this, but this worked already. Okay, So I set the name equals to shred. If body or the target position is not set, I return. I set the number of files that I want to shred equals to a random number between 1, and the number of documents. As you can see, I directly decrement the document by the number of files, but this would be enough to shred one file at a time. If you want to make to work in this way, this is an example. Okay. The talk state, as you can see, I have 3 phrases: sup, oh my god, and hey alihupa. The phrase that it was the picket phrase in here, the timer, so how long the state must last. I set the phrase equals to a random phrase in here. On the stop, I reset the phrase equals to empty quotes. Okay. So I have this behavior research as well. So as you can see, I have a key, a remaining, and a state that is a packed array of strings. So this behavior research will be used to repopulate, let me put it this way, the state queue with the set state. Okay, when I explain the state machine, that is the behavior, it will be clear. Okay, this is the behavior or state machine. So I have one signal called on finish signal, NRNG, the current state of this state machine, a dictionary of states that belongs to this behavior, a dictionary of behaviors that will hold a string, and some data from that behavior research as well. The current behavior, the state queue, the state history, if it is useful for you. If not, you can remove it if you want. And the orange, so this could be the entity. For example, I refer in some states. For example, if I have a base script, for example, for the player, for monsters, and so on, it could be in this part. Okay, the skip precondition, condition, plus condition here equals to false. So this will be only used inside of the states. Okay. Here I also have untype and switch untype, but they are both even though they are similar names, they have different purpose. So that's why I keep it separated. So I have a type that will hold the value of the switch type, and as you can see, iteration, random, weighted, and individual. So in the ready function, I set the orange equals to get parent. So as you might conclude, since every single state and this state machine as well, as you can see, extends node, so they are node, they must be add child, so they have to be attached to a node in order to the process and physics process function being called, unless you call this both methods manually inside of another node. Okay, I have a method add behavior, so based on the behavior research. So I set the behavior dictionary in the position of the set key, the remaining times, and the state, that is an array of states. Okay, so here in the switch, I print the current state queue. So actually this is pretty useful for the debugging phase. So I check if the current state is set, so it's not equals to null. And if it is processing, I stop it. And if the state from the parameter is set, actually I could move this line instead of this. So I'm doing it. So if the state is set, I append to the history the name of the state, set the current state equal to this state, and I call start in the current state. So if the current state is connected to the finish state, is not connected to the finish state, I connect it. And if the current state behavior is different from this state machine, this behavior, I update. Okay, So in the finish state, I match the type. So if it is the type iteration, I basically pop the first state inside of the state queue, and I access the dictionary of state, calling calling the method switch passing this one. Okay, so the state queue basically I pop the first occurrence of the array. If not, I call behavior switch. If the type is the type random, I set the key equals to the state dictionary dot keys and get a random number between 0 and the state size less 1. But in this and the other one and the others one as well, if the state queue is greater than 0, so actually the state queue has priority, and this actually allows us to make a lot of things. I will explain soon. But basically the state queue now use the state queue pop front, so I don't use a random state from the state dictionary. Okay, so I actually prioritize the state queue. In the random widget is the same idea. I get the keys, I get the weights by looping inside of the states, and I append that weight attribute from the each state, as you can see right here. So now I create an array of weights, and now I am able to use range weighted passing these weights. Okay, but the state queue is also prioritized. If you want to have actually an if and else and have this inside of the else, it's up to you. But I think this is the way that I don't need to use if and else. Only if is enough. Okay? And if it is individual, I basically check the state queue to use it, or if the current state have the next state, and so I call the get next state, and if the key is equal to empty string, so I don't have any state exactly, in order to prevent error, I just return. Okay? So remember, this get next state is where you have that iteration or random, or like this actually is particular for each state. Okay, and this behavior switch. So I check if the behavior dictionary has this current behavior, and if the remaining time is equal to -1, so it's not set, or if the remaining is greater than 0. If it is, I set the state queue equals to the behavior, passing the current behavior, accessing the states array, duplicating. So just like, because Godot has this idea of objects, array, dictionaries, and objects, like instance, are passed by reference. So in order to pop inside of one of these methods and actually pop inside of the behavior, I don't have this trouble. And I check if it is set, I decrement the remaining times by 1, and I call switch passing the now populated state queue, and I call unfinished behavior, because this must be called like in the end of each state queue. That actually is the end of the behavior itself. Okay? And as an example, I have this wonder resource. So as you can see, the name of this resource is wonder. The remaining times is equal to -1. So actually this can go forever. And the state inside of this is just move to. And I will explain. And I have an example of this usage. But basically this is the whole behavior system. And now let's go to the example. So first of all, I have this entity. So with a sprite, with a collision shape, this array2d that is detecting like the same layer, and this is the collision shape. Inside of the script entity, so as you can see, I have a behavior that is the state machine, the state move, that is the move to state, the state hug, that is a hug state, and a hug cooldown. I want to explain this because this is not the first example. So I set the body to the movie state equals to self, connect the onStop to the function method reached that it will show soon. The entity for the hug as well is self. The hug time limit is 2, and on stop, so upon stop the hug state, I set the hug cooldown equals to 1. I add both states inside of my state machine behavior, as you can see, and I call reached passing null. So I will skip this part for now. I loop inside of the behavior get children because every single state is inside of this behavior node that is the state machine. I update the behavior of each state equals to this behavior, and I populate that state dictionary by using the name of the node passing the node itself. So this is a very fast way to populate that state dictionary, and I add the behavior as well to the symmetry, in this case to the entity node. I set the current behavior equals to wonder. I add this behavior that is my wonder resource, and I call finish state. So that reached method, as you can see, using the state parameter, because it will throw an exception because every single thing inside of the state I emit passing the current state. Okay, so I basically set the target position from the state equals to a random number. So, and that's the reason I call in here passing null, just because I want to set a random starting point. Okay, so upon something enter the area, I check if this something has a parent. I set the monitoring of this area to the equals to false, set the hug target equals to this area.getParent, and I access this state queue, and I push front, so I append in the front, but append is actually in the end of the array, so this push front is in the start, the beginning of the array, passing the hug.name. So I actually accessing this state queue, adding the name of the hug state. But so remember, in this case, differently from the turn system, this state queue, I actually use the name of the state. Okay. In the processing, if the area is not monitoring, so it was turned off by this, and it is set, so I check if it is greater than 0, if it is incremented by delta, else I reset the cooldown equals to -1, so it won't fall in this part again, and I set this monitoring equals to true. So by this behavior, my entity basically will move around the scene, and upon something enters this area, it will try to hug basically for 1 second. Actually 1 second, for 2 seconds, right? Yes. So I want to highlight this part because I check if aria.getParent, but actually you could use aria.owner, but since my example do not have a scene by itself, if I try to access the owner, I actually access the root node, like the scene tree. So instead, like this scene. So instead, I actually just access the parent. Okay. Now let's go to the board. I have this entity. So in the middle one is my player, for example, and I have this character body 2D that have the same like the structure, sprite, collision shape, an area 2D, detecting mask 1. Okay, but only my entity will move because I attached my script only to it. So basically, our entity will move around and hug this entity open. Just to highlight, I turned on this visible collision shape, so you're able to see how everything is working. So my player is moving around, as you can see, moving around, entered. the area. So it will go back to hug and then move around again, and then upon reaching the next position, it will hug. And remember, our hug speed is 50 and the moving is faster. So as you can see, it is working everything all together. So basically that is it, right? But only after our entity reaches a certain position, it will go back to hug. But I have some examples where this is interrupted. Okay, so as you can see in the printing part, I start to move, stop, started, I started, stopped, started, stop, started, stopped. And in here, as you can see, I stopped to move, I started to hug, I stopped to hug, and go back. So everything is working, right? So now let's go to another example. So for this one, I need to turn off some certain things. So I will turn off this part, for example. Mainly because I don't need it, but it as well throw some, like, you not to throw an exception, but causing some certain like unwanted behavior. Let's go. So my entity has an attribute document that basically an integer counting current document. I have the refill state that is moved to, a shred state that is a move to, a store state that is a move to, and a state deliver that is a move to. So as you can see, even though I have that state, because how I built this scene, I actually can use every single one of the desired states actually as a move to state. Okay, so here and the refill. So in every single one, I pass the body as self, the name, refill, shred, store, and deliver. As you can see, I add to the state machine the respective states. So this will work as well. So this is the scene. So I have this refill area, the shred area, the storage area, the deliver area, and in the upper right corner, I have a label that I will use to display the current number of documents. Okay, so inside of the Office script, as you can see, upon entering the shred area, storage area, and deliver area, I check if the document is lesser or equals to 0. If it is, I push the current state, and then I push from the refill. So basically, I add the deliver inside of it, and then I add the state refill in front of it. So I have actually my state queue will be the refill first, because I push front after, and then the delivery or the store in this case. And here I decrement by a random value. I had to like separate because the name of the states in this case is the states deliver, and this is case is the state store. But if it was similar, I could actually use the same method. Okay. So in the process function, I set that label control equals to the document column plus like the casted version of the document of the entity. Okay, so in the refill enter area, so I basically add a random number between 1 and 9 to the entity. Okay, so for example, in this shred enter area, I could, if I was using that state, everything would work all together, except this part, because I wouldn't like automatically decrement the number of documents in here. Okay, and okay, now to the ready function of this offset. So I set the type equals to random. So I will basically decide if I will go to the deliver or to storage or to whatever I want randomly. Okay. So I update every single target position of the set area to the respective area global position. But in the state refill, I have a precondition. So if my document is greater than 0, I won't refill, okay? So this won't be used, so whatever, because our switching type is random, and I call finish state to start everything, okay? So if I hit play, so as you can see that I have 0, so it must refill. So it will refill first. Now I have 6 documents, and it will try to deliver again. So now I have 3, and now we'll shred. Okay, 1 document, so now it is random, remember, so it will deliver again. So it would try to shred again, but there is no document, so it will refill, and then shred. Then it will store. Then it would try to shred again, and it will refill. But the same way that I add a precondition to the refill to not refill if the document is equal to 0, I could add a precondition to every single state to check if there is document. So instead of only after reaching that area, it will check for documents, and if there is none, it will go back to the refill. Actually, I could do this before everything, okay? So this is a very basic example, and it was an example that I said in the beginning of the video, okay? So as you can see, a lot of starting, but remember, I tried to deliver first. So as you can see, I pushed the deliver and then I pushed the refill state. But since the finish state pop, the first one, it wasn't printed, okay? But instead of use the random decision type, let's use a random widget. So my chance to go to deliver is 70%, the chance to go to the storage is 20%, and the chance to go to the shred is 10%, okay? So now we must actually send the entity, the player, the NPC in this case, go more often to the deliver than anything else. So let's check. So deliver, no files. Go back to the refill. Then again. It started 20%, then deliver again, no files. Let me accelerate. Thanks Godot to have this. So 2 times the speed, so deliver again. Okay, shred, then deliver, then start, then deliver. So as you can see, the deliver one is way more required than the rest because of this random widget, okay? So now we are way better, like we have entities that is a bit better, like a bit more smart than the rest, right? But now let's go to the final example. So in this case, the entity doesn't matter. So it must move around, okay? So I will actually okay, so now that everything is commented, I will close the entity script, and now let's go to the boss. So as you can see, I have my entity right here and my boss right here. Even though I have this script of the boss is seen, it does not have anything. Okay, so I will close this one. And now let's go to the boss script. So I have the behavior that is my state machine, the move to, talk, idle, ray, and hit. So for these three examples, I use the state class. So that's the reason I didn't set the state as final, because I can totally use as a default and basically one. Okay, so I set the move, the body, and the speed to self 100. The talk, it must last 2.5 seconds. The idle with the name idle during 1.5 seconds. The hit with the name hit. The ray with the name ray. The time limit equals to 1. And the behavior type, the decision one, will be individual. So as you can see, I set the name right here and some other things. Why? Because I'm not using a custom state. Okay, so if I had this custom state, actually these infos would be inside of the ready or the init function of each state. But since this is like a generic one, so I'm setting right here. Okay, I add every single state inside of the behavior node. So I start setting. So to the hit state work, I check if the player is set. So I actually use get first node of in the group player, and I check if the player is exists if the distance is greater than 64. So the state hit won't work if the player is not set or the distance is greater than 64. Okay, this is my precondition, and and connected to this precondition signal, I actually add set the target position to the player position. I add push front the hit, then the move. So actually it will be the move first and then the hit, and the call finish state. So actually the hit state would check if the player is if it is further than 64 units. If it is, it will call this, it will emit this signal that it will actually set the state move and then the hit state again. And the state hit on start, I enable the collision shape or I set the disable equals to false. I wait for 0.25 seconds. Then I set deferred because I just set this and I am setting in another function methods as well. I set deferred, so disable equals to true. So as you can see right here in the hit area, the collision shape is disabled. Okay, so it won't detect anything. So in the on start correctly, this will be set to false. So now my boss is able to detect and hit. Okay, then it will stop the state. Okay, because I do not have anything processing, so this state wouldn't stop if I call here manually. Okay, if you had, for example, a time limit to the hit state, or if you have another thing that would stop this hit state, so okay. But since I do not have, I call it manually. Okay, and the rate as well. So as you can see on the start, I set this marker 2D to look at the player global position, and basically 3 times I enable the recast, wait for 0.1 second, and then disable again using set deferred. So as you can see here in the ray state, the enable is turned off. Okay, and upon the ray stop, I also make sure this is disabled, and I also check right before everything this on state move the stop of it to the finish state. Why? Because since the hit might call this and these are not this didn't pass for that switch that connect to the finished state first. So actually this might not work. Like this move state might not like stop and call the next one. Okay. So each state has its own next possible step. So as you can see, so the bus after talk can idle, hit, or use the ray. And it will use the switch type equals to iteration. Okay, so it will open after talk, it will first idle, then the next time it will talk, it will hit, and the next time it will talk, it will use the ray, and then go back to the idle. The idle state only has the possible state hit. So even though I set this random, it won't work exactly. But basically, after I go idle, the only path next state is hit. So now I have something like a logical gate. Let me put it this way. I start to talk, for example. If I go idle, the only possible state for the idle is hit. Okay. The hit one can go to rate or talk, as I set the weight 0.2 and 0.8. So as you can see, after I hit the boss hit, it is more likely to talk again. And the ray states are hit and talk. And I actually use a callable, and this callable basically pick a random value. Okay, I'm sorry because to not think a bit more complex example to use this. Okay, but like you can create that. Imagine that circular neurons that some tutorials has connected to each other. So we have the talk, like in the top one. It has three like possible paths: the idle, the hit, and the ray. But the idle only one, that is hit, and hit only two, ray and talk, and ray only hit and talk. So if I start talk, I will go idle, and idle can only go to the hit. So if I go talk, I actually go hit again, for example, or go to the ray, and so on. I think in the I think that the practical example is better to see. So I do the same thing, populate the behavior as this state machine, and I call switch. Okay. So the process, if the current state is set, this label state will have the name. If the state talk exists, the phrase label will hold the label, the phrase string. Okay. So if the ray cast is colliding, I call move player, and this move player basically moves the entity to a random position and open the hit. So the hit, not like dealing damage because I do not have the attribute system right here, but basically the boss will hit the player either by using the hit or the ray cast, and upon colliding with one of these two possibilities, the player will teleport to a random position. Okay, so this is the whole thing. Now let's go if this works. So just to show you, this is the phrase, this is the state, this is the marker with the recast right here, 300, the hit area, and the collision shape to it, as you can see. Okay, the collision shape and the sprite. Okay, now let's go to the boss. So if I hit play, so idle, move 2 because it tried to hit, and now hit, talk, okay, move again, hit, talk again, ray, okay, now, so as you can see, it is deciding what it will be the next step, like the next state. And actually it is like different ways to decide, right? That after talk, it is iteration. So it will like eventually hit it either idle or hit or ray. The ray can only go to hit or talk, and the hit, talk, or ray, and so on. So now we have a way like a better decision for the entity, and this is what used to be called artificial intelligence, okay, AI. So guys, that's it. I hope, like, even though this is not the most exciting boss fight you ever saw, as you can see, it is very like complete, at least in my point of view, since this is 100% original, and I didn't use this in every single possible let me put it this way, even every single possible situation this can be used. So these might have like minor flaws, but as I said, this is more than enough for most part of the things I might want to build. Okay, and remember, since I also have the behavior research and so on, I actually might have this boss with, for example, phase 2. I just would need to repopulate the state dictionary. Do you understand? So that's it. I hope you enjoyed. I hope this was useful. I spent like the last 3 days in it, so I hope it was useful for you as well. The code will be available in my GitHub. Okay, so thanks for watching and see you in the next video. Bye.